This is the math behind Matt Parker's Thursday video. And quickly, Matt Parker, which I love all of his videos, created a video on January 3rd, which was a Thursday, and he claims that that's called Thirdsday. And he had a rope and he showed an iterative way to guess at 1/3 of his rope. And it was quite interesting. And he references a video by James Tanton on how to fold or split things into thirds. Matt Parker used a rope. James used a tie, and they also used pieces of candy to divide it into thirds. So let's quickly describe what they illustrated. And there was no math in those videos, and that's kind of what spurred this video on. Now, we're not going to go through the R code because I really just want to show you the math behind it. So we have some length of something. I'm going to call it a length of 1. And you guess at 1/3. Then whatever's left over, you have it. And that half is the new guess for 1/3. And then you iteratively do this. So if this is our guess for 1/3, which is, of course, a little more than 1/3, you take what's left over, half it, and then that half becomes the new guess for 1/3. And this is just repeated. Then this is the new guess, and then you split the remaining into half, and then that's your new guess. And you just keep doing it, and it limits to 1/3. You find 1/3 of the length of whatever you're trying to find. And I thought that was so cool, and I wanted to investigate the math behind it. And another aspect is you notice that the error of 1/3 tends to decrease. And in the video by James, he claimed that each guess, the error is halved. So this was our first guess, and this is the error associated with it. And then our second guess is here, and our third and our fourth. And it does appear to be that the errors are decreasing by 1/2 each time. So we're also going to investigate that. So here's the process. You take an initial guess, and then each successive guess is you take whatever's remaining, half it, and then that's your new guess. And that's an iterative process. And we want to show that limits to 1/3 as n goes to infinity. Now, it's pretty straightforward to show that the sequence is bounded by 0 and 1. And the reason I'm doing that, if you can find a bounded sequence, then it's often easier to find its limiting value. But one downside, this isn't a monotonic sequence because it bounces a little over and a little under 1/3 each time. So then there may be some theorems that I'm unaware of, but that means that we can't just easily show that it limits to 1/3. And I'll show you what that means here. So if the sequence is bounded and it's monotonic, that means there's guaranteed a limit. Okay. So if we know that, then we can use this technique. But we don't know this because it's not monotonic. If it was monotonic, you could say you want to find the limiting value of this sequence, call it L, and then we can replace AN what its previous term was, and the limit of this is the same as this, but the only thing changing is this. But it has the same limit as AN, so we can replace it with L. And then you can back solve and show that L is 1/3. But I don't think that we can use that just right away. So let's use more of the definition of limit to prove that it limits to 1/3. So we want to find the limit of this sequence minus 1/3. Now, if that goes to 0, then that shows that AN, the sequence, limits to 1/3. What I do is I keep 1/3 the same, but I put in its previous term, which is, 1 minus an divided by 2, and then that's the next guess. But then I put in its previous term. And you can show the math that it's this, that it's 1/2 minus 1/2 squared plus the two previous terms over 2 squared. And we can continue. So since we're at n, we can keep doing this until we get to the first term, a1, which is our initial guess. And you can show that this piece is this, and it's alternating signs. And then, of course, the 1/3 comes down. And in this sequence, you can show that it's this. Okay. Now let's let n go to infinity. And, of course, this term, there's no n, so it's just what it is. And since this is a fixed value, that's our initial guess, and it's being blown up by this number, it goes to 0. And then you can easily show that that is 1/3, that it limits to 1/3. And so this quantity does limit to 0, which shows that an limits to 1/3. Now, to examine the error that James said, that it decreases by half each time, let's look at that. So this is the nth guess, right? And we'll see its error from 1/3. And this is the next guess, and let's look at its error. And I put in what an plus 1 is. Okay. I multiply the numerator by 6 and the denominator by 6 to get here. Then, of course, this is minus 1, and then this is 3a. And then I factor out a 2 in the denominator. And these are just multiples of each other, minus 1. That's what we get here. And absolute value minus 1 is 1. So it is 1/2. So the errors do decrease by a half. Well, that's the math behind Matt Parker's Thirdsday video. Hope you enjoyed it. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.